All right, enough of me. Let's get into our final block. We have Jitesh and David from the BBC, and I'll hand it over to them.
Hello, everyone. My name's David Buckhurst. I'm an engineering manager at the BBC, and I look after the teams that build our TV applications, console, set-top box apps.
My name is Gosai. I'm a test manager for the Titan team, which is the BBC's test tools and infrastructure team, and we bring software engineering skills to our test department.
So we work for BBC Design and Engineering, which is the technology group within the BBC. So people think of the BBC as a broadcaster or a news outlet, but to me, the BBC is a great technology innovator. And so 80, 90 years ago, the BBC was there, big part of the development of TV and radio broadcast technology. We had our own computer in the 80s. Robotics is obviously a big part of what we do. More recently, I guess, the internet age, we were one of the very first companies to have a video-on-demand application in iPlayer. It's been around over 10 years now. So I think the last time I counted, we had about 30 mobile applications and 4 TV apps across a whole range of devices, which is kind of what we're going to talk about today. In trying to scale our automated tests to cover as many devices as possible, we started to learn the real challenges and actually the value in test automation and where that value was. So one of the things that makes the BBC unique is the way that it's funded. So we're publicly funded. It's not a government tax, but a license fee. And that gives us a very large remit that's established. Our mission in the Royal Charter is signed by the Queen. This is the one I keep on my desk. But basically, our mission, which is inform, educate, entertain, there's 2 very important parts, which is very relevant to what we're talking about today. So our focus isn't on profit or growth, but in value for money and reach. So value has to be a big part of everything we do, and also reach. So specifically something we refer to as the universal obligation. So what that means to us in design and engineering is that we have to ensure that our services are available to as wide an audience in the UK as possible. And so if you think about smartphones, TVs, and we've had other speakers the last 2 days talking about device fragmentation, we can't actually just choose which devices we support based on capability. We have to get our apps to work on the devices where the audience is. So that means it could be a $50 tablet or it could be a $5,000 smart TV. And in fact, we started really to become overwhelmed by the challenges of manual regression.
So to get us started, we start with behavior-driven development, or BDD, to first understand exactly what it is that we're trying to build. And what we started to do was run 3 Amigo sessions. So we got our developers, our testers, and product owners all come together and collaboratively understand exactly what it is we're trying to build. With this, we'd then produce a feature file. This will list the key scenarios or acceptance criteria for that feature, and we use this as a starting place for what we were going to automate. And we got pretty good at automating this way, and we got them running on physical devices. But the problem was, we still had these massively long-running regression test cycles. So what we wanted to do was take these automated tests and actually run them on as many different devices as possible. This way, if those tests passed, not only had we satisfied the acceptance criteria, but now also had an executable specification. So we got pretty good at doing this, and so we came up with some quite innovative solutions. Here, one of our dev teams actually grabbed a load of phones that they wanted, grabbed a spare chair and a laptop, and actually stuck it to it, and would actually move around a mobile device testing rig. So they could actually wheel this around to wherever they were, run the test, and actually deal with any issues that came up. Problem was, this wasn't very scalable. I mean, we had 20-odd development teams, and building a test rig like this for each one wasn't really going to work. And also, each team would then actually have to reinvent the wheel every time, understanding how to get the test to run on all the different devices, deal with the Wi-Fi issues, the stub data issues, and generally just having the devices in a state that would run the automated tests. So what we did was we created the Titan team, which is this test tools and infrastructure team. And these are software engineers embedded within the test discipline to help build test tooling and infrastructure for the test department. And one of the first things we got these guys to build was a test rig, which they called the Hive TI. And they build, maintain, and run this for the whole of the BBC, and it gives us 4 main features.
So yeah, so one of the big things that the Hive does for us is it just keeps devices in a state that's ready for testing. So if anyone's done a lot of trying to run automated tests or even just do manual testing on device, well, the first challenge is find the device. It's probably hidden in a drawer somewhere. Once you've found it, you have to then charge it. You have to get it on the right Wi-Fi network. You then have to clear off the SD card that's been filled up with screenshots. And so what we really wanted was a system where we could just plug a device in and it'd be ready to go. So the picture here is actually for our TV applications. So what we do is this is essentially a holding app. We can launch a television into the holding app through basically broadcast hooks, and then it's ready and waiting to run tests. So the second thing that the Hive does for us is inventory management and monitoring. So, no good just having all these devices there if we don't know what state they're in. And really, we wanted a totally zero-effort approach to having an inventory of devices. So we can literally just plug a device in, it registers, we know what the type of device it is, we know what state it's in, and we're ready to go. And also, it's so you can see a number of those devices are red. They've, whether they've fallen off the network or the Wi-Fi's gone flaky or the SD card's filled up, someone can go and investigate that device. And importantly, they stop running tests. But also, more recently, we've got a bit more advanced, and some of the devices they can actually recover, so they'll try and clear off the SD card, they'll try and fix the Wi-Fi settings. And I guess a real key thing that the Hive does is actually run those tests. So teams anywhere in the BBC can write tests. They can then choose which tests they want to run on, which devices they want them to run on, and then the Hive just manages that scheduling for them, so they don't have to kind of worry about that bit. And it'll also do things like retries. So if there's flaky tests or anything like that, it'll retry them. I think we allow a single retry, don't we, for every test. And importantly, because it's like every team across the BBC, all building apps, they're all using different frameworks, so it really has to support any type of framework that people be using to automate their tests. And then a final kind of the fourth big thing that the Hive does for us is just result collation. So if you imagine for a release of iPlayer, our video on demand app, we might have 100 to 1,000 different test runs. We want to bring that together in a view so you can just see at a glance, oh, there's no failures, or if there are, you can drill down and investigate them. And also, it smooths out any flakiness we've got, so that the developers don't have to worry about where our tests might not be so solid. So this is an example of Jit's team setting up one of our TV hives. So we found this corridor that didn't seem to be in use. It turned out it was a fire escape, but it's an absolute brilliant place to build your testing setup. So, and that's just running all our TVs on the holding app. They're ready to run tests. In fact, some of them are running tests. This is kind of more typically what a mobile hive might look like. So we can kind of set these up anywhere, just inexpensive PC hardware, running Linux and our Hive daemons, and just plug in a device, it registers, it's on the system, it can run tests. And then for iOS, we do the same with Mac Minis.
So we started to get pretty good at writing automated tests, maybe a little too good, and a lot of our dev teams were starting to struggle with exactly what was in these test suites. They had so many now that they didn't understand what was and wasn't tested anymore. We also started to drown in a sea of flaky red tests. Whenever anything went wrong, they wouldn't know whether it was an actual defect, an issue with the test framework itself, or actually an infrastructure issue. So, and the burden on these teams just to try to maintain these tests was getting bigger and bigger, and the value that they were giving was just getting less and less, and they were starting to ignore them. So we looked into seeing what we could do next to try and see, how can we help these teams deal with this test automation issue that they're having. So we went back to the test pyramid, and we looked at the automated tests that we had, and we looked to see how many of them we could push down into the integration and unit test levels, where they'd run a lot faster, a lot more reliable, and a lot easier to write. But we did want some automated UI tests. We were trying to create the peak of the pyramid. And we started speaking to our dev teams, and they all mentioned that they were running a small suite of tests all the time, kind of like a core suite of tests, or smoke tests. They all had slightly different names for them, and they all had slightly different tests, and some were bigger suites and some were smaller suites. So we looked into these principles that these guys were running and created a new term called Puma tests. One of the first things those teams said is, what the hell are Puma tests? Well, it's actually an acronym. It stands for Proves Core Functionality, Understood by All, Mandatory, and Automated. So we take the first two, proves core functionality. What is the main thing your app should do? For us, our app was a video on demand service, so it's video playback. It doesn't really matter if you can add it to favorites, download a program. If you can't play that video back, your end users are just going to leave. So what is the core thing your app should do? Understood by all. Our dev teams didn't understand what was and wasn't being automated anymore. So it's up to those teams to come up with those tests themselves. But not only that, everyone within that team must be able to execute those tests, whether they're technical or not. And also the status of those tests should be visible to the whole team, either via our dashboards or email notifications. Mandatory. It's got to form a part of your delivery pipeline. Whenever developers commit any piece of code and an app is built, the Puma tests are run. If those tests fail, everything stops dead. You don't get no release, nothing gets pushed to live. It's up to the team to then debug those tests and figure out exactly what has gone wrong. And last but not least, automated. It's got to give you fast feedback. It's got to run in 5 minutes or less, and it's got to run on representative devices of your end users. Now, one of the key reasons of calling them Puma tests was it gave the team a common language. When they said, what are your Puma tests, they knew exactly what they were. But it also stopped them from putting in tests that weren't related to Puma tests. So any other suites that they want to create, they could create them, but it keeps the Puma suite very small, focused, and fast.
So Pumas were a big success for us, and when we were looking at the kind of 200-odd tests we'd have that were across the whole UI and trying to boil that down into sort of 10 really useful core tests, we started to look a bit more about what we were actually testing and what was that core focus of the application. So thinking about a video-on-demand app, video playback is surely the most important thing that we're actually validating. And what we realized is that although we had tests that took every single journey to the play button, there was nothing that actually pressed play and validated that playback was happening. So, and part of that was because some of the automation frameworks we were using didn't really support that kind of journey, that kind of testing. So, but instead of spending all the effort in building out all these applications, focusing that time instead on just building some simple libraries that would help us do things like confirm, is video actually playing back on this device, or is audio coming out of the headphone jack? So as well as kind of focusing our core test to the stuff that was really useful, we also started to think a bit more about the kind of tests that are actually really useful to run on devices. So things like performance tests, where actually you do want to be able to run those on devices and see what the difference is. So for example, live video is very important to us. So we were looking at what are the start times for live video playback, and that was just information we didn't have before.
So when the Hive wasn't running automated tests and the testers weren't actually using the physical devices, they weren't actually doing much else. So we thought, well, why not use these devices to run tests every couple of hours and give us performance feedback on what our app was actually doing? And so to try and help the team keep focused and have a common language of what these types of tests should be, we came up with a new acronym, again following the CAT theme, called LION, or Live Insights and Operational Notifications. Now, behind these tests is to run every hour, and these will give us data on how long did the app take to start, how long to video playback, does video playback, how long are our core journeys taking, and then putting canary tests around these areas, or threshold type notifications. So if it went above or below a certain mark, it would inform the team straight away and let them know that, their app's performing in a different way. This way they didn't have to wait for the end users to tell them, but they actually had these tests running constantly throughout the day across the representative devices. As David mentioned earlier, our remit is to reach a wider audience as possible, and so we need to make sure our app is accessible as possible as well. This is a picture of one of our colleagues Ben Mustel-Rose, who has actually helped us build a lot of accessibility testing and actually automate some of the feedback loops around here. So what we do is we've leveraged the Hive to actually use screen readers as devices on the Hive. And what we can do is we can actually send our Puma test to the Hive, enable the screen readers, and then capture the output, and then compare that against a known set of good output, and then report the difference back to our dev teams. Now, it's not necessarily automating accessibility testing, but what it does do is it gets our dev teams thinking about accessibility a lot earlier than they did before. Whereas before, they'd actually release the app and then wait for feedback from the external users. Now they're thinking about it every time they're committing a piece of code and producing a build and thinking, oh, hold on, how is this affecting this core journey? And letting them think about accessibility testing a lot further down the stream.
So to iterate some of the points what we said, so it's all about value for us. So, and the last kind of 4 or 5 years have been this journey of discovering that in trying to scale our automated testing, we were kind of missing the point of the value of them. And I think those learnings are really kind of two things. So one is to focus certainly your UI tests on the absolute core journeys and push everything else down the pyramid. And the second one is to focus on the things that are really valuable to run on devices, so performance tests, compliance tests, and that's where you really get the return for the amount of effort you have to put into this kind of thing. So if you want to find out more about our approach or tools, check out our open source website. So everything we've talked about today, it's developed in the open on our GitHub BBC org. So if you want to set up your own device cloud internally, or you just want to look at our Puma approach or try out some of our libraries, please give it a go and talk to us if you've got any questions. Thank you.
Thank you.
Great, thank you both. Let's go into questions. I don't have any Woody comments at this point other than to see, I guess, across the pond, there's a lot of the same issues we run into.
That's right.
What do you use to automate actual video playback verification?
So, what we tend to do is a very, very simple approach that just works across as many devices as possible, which, an ADB screenshot frequently to literally just capture, every half a second images. Are you getting enough of a diff that you can confirm that video is playing back? And that's actually been amazingly successful. It can spot when we've got buffering problems. It can,
yeah, exactly. It's been really good. You'd be surprised at how the diffs actually have a unique fingerprint. So we've actually been able to identify when a program's actually starting and actually how one program's different to the other. So it's been very simple, but it's worked surprisingly well.
Yeah, we've not found we needed anything more complicated than that.
No.
It's really fulfilled everything we needed.
When are you going to open source it?
It's all open source.
All open sourced. Oh yeah, was that on the last slide?
Yep.
There you go. I am paying attention at this point. So, some images of your player show that it supports cast. How do you test cast functionality?
Same way most people do, by actually setting up a cast and connecting to it. We haven't actually managed to automate this yet. We've had all sorts of issues within our own buildings with Wi-Fi networks and casting to different casts themselves. So right now, that's still very much a manual process. We have some stubs within the app which will mimic a cast being there, and so we can automate the functionality of it. Or does the cast button show? Does the cast button not show? Do our hooks within the app which kill cast on and off work? But the actual casting of it itself is still very much a manual effort. What we found is actually we still need a human person sitting there telling us actually not only does it cast, but the experience of casting is actually as good as we expect it to be. So, I mean, we can automate it, that's fine, we can know it would cast, but it still doesn't tell us how good it is. And it's no good if it casts to a TV and then we don't know if it's actually playing anything, or the audio is not there, or it's stuttering, or it's just a really poor experience.
Any questions in the room? I'll head over that way, but how about 4K playback? How do you test it?
Not got any 4K playback yet, but that's something we are working
coming,
on. Yeah.
Hey guys, so it's really interesting. I'm from the app business over in King's Cross, and we've literally got the same problem, and we are working on something to do with testing those core journeys and stuff. And it seems a lot of other people have hit the same snag. Why do you think it's happened now that we're starting to see this whole scale versus value, and that we're having to look at picking and choosing the right tests to run?
Do you want to say that?
you can take
So for what we found is 4 years ago, everyone said, look at the test pyramid. And it said, push everything down into the lower levels. But before, say 5 or 6 years ago, if you wanted to automate anything on mobile, you just couldn't do it. And then all of a sudden, all these tools started showing up. Appium, Calabash, and then now native support via Espresso, Robotium, Xcode UI testing. So everyone just went pretty much mad and thought, right, we can automate the hell out of all this. And not only that, we don't have to get our developers to do this anymore. We can outsource this to test engineers or software engineers to test, developers and test. And so what we all did was built loads of automated UI tests. Because it was easy, well, it seemed easy, and we can just build more and more and more. And then you started running into problems of, hold on, how do you run this on so many different devices? How do we, bring down the test times? We can parallelize it as much as you want. You can stub out the test data. You can do all this. But actually what we realized, none of this was actually helping us. Bugs are still getting out there. I mean, the automated tests only check a very thin, narrow path of your app. Anything beyond that, it's not going to check. And also what we found was, it wasn't telling us whether or not the experience was any good for end users, whether the video playback was of a good quality for us, or audio playback was of any good. So what we started to realize was few core tests were actually telling us the most. Does the app start? Can I get to the main features of the app? Can I hit the play button? And actually they were good enough. And we can push a lot of the other testing lower down level, and then actually have our people testers, our manual testers or beta test programs tell us exactly how it's actually performing, and do people enjoy using it. So I think that it's been a journey for a lot of us. Even though we all knew we should be pushing it down, we all kind of tried it and gone, okay, no, this doesn't work. I've been fortunate to talk to a lot of other organizations, and they've all hit the same thing as us, some only having 3 main automated UI tests and saying that's enough for us. So that's my 2 pence.
Very good. Well, thanks, Jitesh and David.
Thank you.
Excellent.